ready?
All right, everyone. This is the last talk of today, and then after the talk, everyone's going to stay here because we're going to get everyone else to come in here to do the final sponsored talks, or pitches, I should say, which are only like a minute each. And then I will close, and then we'll come back again tomorrow. So I'm going to, introduce Sebastián. Let's give him a quick hand. He's going to talk about external secrets.
All right. Thank you. Can you hear me okay? Is it on? I can. All right, cool. Well, thank you. Thank you for sticking out this late. I know everybody wants to get out of here. It's been a long day. But I'm gonna talk about this project, an open source project that I'm really excited about, that I've been working for the last almost 3 years. And also I was supposed to deliver this talk before at 3, so I was told that wasn't going to happen, so I went out and had some beers, so I'm giving this talk under the influence right now. I hope you guys don't mind. And I had a little poll. I was expecting a little more people. Who here has heard about the external secret operator or know anything about external secret operator? Okay, that's good. So you can leave. No, please stay. I have a few new tricks to show. So my name is Sebastián Gómez. I go by Seb. I work at Ubisoft. I have a developer background with some ops. I have fun trying to automate everything that I can. But I'm here as a maintainer. This project that I'm going to show you is called External Security Operator, and there's 5 maintainers. Yeah, we're 5, so we need help. I'm gonna get to that at the end. And yeah, that's me working through the World Cup last summer. Disclaimer, I'm going to be saying secrets a lot. I'm going to say secrets referring to the kind secret in Kubernetes. I'm going to be saying secrets because of secret credentials. I'll try to make it easy to understand. Let's see how it goes. So I'm going to show you a problem, the problem that we're trying to solve, a problem that I think is very, very common, a lot of people has. And then I'm going to show you a solution, and you might want to look surprised when I tell you what the solution is. So here's the problem. Let's say you have an application, and your application has access to a database, and your application also needs some external resources, and you have, I don't know, you connect to an external API. It might be they gave you a token to connect to that API. It could be they gave you, I don't know, user, password, key, secret, whatever. So those dotted lines that you see there, those are, it's critical data, right? These are secrets. These are credentials that you need to store somewhere safe. You don't want that to be out in the wild. So let's say now you have 3 environments for the same application. You have your dev, testing, and production. You obviously have different databases. You do have access to the same external resource, but you probably have different credentials, one for each environment. So the amount of credentials start to grow a little bit. And let's say now you break those monoliths and have some services. Let's not call it microservices, just services. And yeah, but you tend to see like what's going on, right? There's a lot of secrets moving around. So the problem comes with having a multi-service and multi-environment setup in Kubernetes. I forgot to mention that from the beginning. This is a solution for Kubernetes, which I've been giving this talk in a lot of places, and Having it in a place where the name starts with cube is great, because this is exactly for Kubernetes. So yeah, you can end up with hundreds of secrets to manage. It's really hard to handle the rotation of the secrets if you have rotation. Maybe you don't. It's hard to onboard new services. It's hard to onboard new people with specific access. And where do you store them? What do you do with those secrets, with those credentials? And how do you distribute them securely? Do you copy and paste? You send an email, you paste it on Slack? So, by the way, the answer was no to all of them. So, part of the solution is using cloud secrets managers. Every cloud provider, most of them, at least a lot, have a solution for storing secrets. And they handle rotation, they handle obviously encryption at rest, they are secure. We can trust that environment. I would trust that more than my local computer. So that would be part of the solution. Part of the solution would be having those secrets, all those credentials, stored in one of those services, in one of those secret managers. And the other part would be having something that syncs the secrets, pulling the secrets from the cloud provider of your choice and injecting that into your cluster, creating a Kubernetes secret. So, to your surprise, that's exactly what we do. The appeal for syncing secrets is that you probably are already using a cloud provider and you're using other services. But what I mean by this is, it's not like a completely new setup. You probably have or either AWS or Azure or GCP, and they also provide this service. So it's something that you already have out of the box. They have a lot of features, like I mentioned, encryption at rest, rotation. It's also good to declare your secrets in the source code. You don't have to give your developers your secrets or have access to them, and you avoid, what I meant is you avoid the access to the actual secrets. You can have like one person or one team in charge of handling the secrets. So how do we do it? The same way the Kubernetes controller works. This is a Kubernetes cluster. So you have the controller over there, you have the conciliation loop, and when you create a deployment, the conciliation loop says, okay, the controller says, okay, there's a new desired state, there's a new deployment, which one replica, let's say. What do I have to do? I have to create a pod. I have to create a container. I am running out of battery. I can't believe this is happening. But I try to keep talking while I plug it in. So the controller will create the pod and the container, and will keep checking, right? If you create your deployment with 3 replicas, it will create 3 pods, and it will kill if you have changed the desired state. Of course, it will go back to the state that you want. Sorry about that noise. So an operator, the external security operator, what it does is, again, exactly that. It has a reconciliation loop, but it checks for some specific CRDs. We have our own custom resource definitions, which are external secrets and cluster secret store or secret store only. And I will show you how they look like. Sorry, I cannot multitask. I'll be right back. I'm back. All right. So yeah, the way they work is we create in the custom resource that you see over there an external secret. The external secret operator will see that and will find the credentials to go to a cloud provider, whatever that is, and it will eventually create a secret in your cluster. How is that done? We have two CRDs. There's more, but these are the simplest. The external secret and the secret store or cluster secret store. The difference between a secret store and cluster secret store is obviously the cluster secret store is not namespace. But basically in your, can I point with this? So I have an external secret, I have a name, I have a namespace. How often do I want it to refresh? The secret store ref, which is how am I going to get the actual value for that secret? And then the target. I lost it. The target is I'm going to create a secret called, in this case, data by name, and it's going to have a key called secret value that is going to come from the key called secret 1 from the cluster secret store that I mentioned before. In this case, the cluster secret store is the one that says, okay, this is a cluster secret store. It's called AWS SM. Is for AWS Secrets Manager, the region. It says Secrets Manager because we always support parameter stores. And then how to get the credentials for that secret. But let's go to a demo which will help make this clearer. Is this visible enough? Is it? Okay, cool. So, I need to look at that window. Okay, so what I have here is, I already set up, I have a cluster, Minikube cluster in my laptop. I have set up Azure Key Vault, AWS Secret Manager, and a local Vault instance. I have Vault installed also in that cluster. And they all have the same secrets. I use Terraform to create the same secrets with different values, but the same secrets in all those providers. So what I'm going to show you is that I'm going to, let's see. I have a script here which is called apply, and I say AWS Secret Manager, and this is creating. This repo is in GitHub. I will give you the URL if you want to try it. So basically, I created a couple of external secrets, which are here, and they are created for AWS Secrets Manager. Let me show you first. Get cluster secret store. I have 4 cluster secret store for AWS parameter store, Secrets Manager, Azure Key Vault, and Vault. They're all valid. And I should have now external secrets. Yes, and they all have the state sync, which is great. So that should mean that I should have secrets. Yes, created 59 seconds ago, by those external secret operators. So if I go to see the data by name, I want to see the JSON path. This is more difficult than I thought. I don't want a quote there. Data, sorry. Okay, let's start from the beginning. Get secret data by name JSON path. Let me know if I'm screwing up.
Yeah, actually, space between name and dash.
Yes, thank you. JSON path, data. You're still awake. Nice. What's going on? Oh, I put a quote. Yeah, finally. Okay, secret value. The key of the secret was called secret value. So there's a secret. Where's my pipe? Yeah. Yes, hello from AWS Secrets Manager. So what I'm going to do now is I'm going to edit the external secret that created that secret, which I named the same, but you don't have to. This has the same name for demo purposes. Edit. Thank you, Preksha. Okay, so what I'm going to look for is here the cluster secret store ref for that external secret is the one called AWS SM secret store. I'm going to change that and I'm going to put Azure. I showed you I already have a cluster secret store called Azure secret store. So I'm going to save that. And if I ask for exactly the same, for the same secret value, and decode, I should get hello from Azure keyboard. The external secret operator kicked in, saw that I changed something in the external secret reference, and went to a different provider to grab the right value for that secret. We also have we have a couple of new things. Let me delete the secrets. External secrets. Yes. Yes. Okay. Oh, one thing that I did want to show you before I deleted was that we also have a template. And we can actually create secrets with a template. So in this case, this will create a secret with credentials in its data and a file for AWS credentials that I can get from an external secret. So I don't have to only create the keys as such, but I can actually create a template to generate a file the way that I want it, and then I can mount this secret, the generated secret, I can mount it inside any pod that I want. So the other thing we have, and this is new, we have the generators, and let me show you this. Generators password, and password is the kind password. This is something that we create to generate if you need to generate secrets randomly, and then we have an external secret that instead of having a secret store ref to know where to go get the secret from which provider, it has a generator ref, which is saying the secret should be coming from this password called my password. Again, naming things is not my thing. Get secret, my secret password. Password, and this is going to be data password, and let's see what it says, but it's just a random password. Yeah, in our generator we can define, okay, I want the password to be 30 characters long, digits, symbols, the symbol characters that I want, etc. And the last thing is the push secrets, and I'm gonna apply that. I'm going to show you. I created two things. One is a secret, plain secret, my own secret it's called. And I created a push secret. This is something from the external secret operator that is going to use the secret store for Vault, which I mentioned is installed locally in my machine, and yeah, and it's going to push that secret. So I do have Vault here. Those are the secrets that were there, and if I refresh, it will probably ask me for the token, which is root, but it's very secure. And my push secret, there it is. And we can see the value, hello Kubehuddle Toronto 2023, which should be the exact code of this. We can try, but you can trust me by now probably. Why do I keep typing? So yeah, it has a secret key, which is what I grabbed from it. This is a JSON. And yeah. So, Costo.
So when you push the secret to the vault, what's the version of the key when synced to the vault? Is it key version 2 or version 1?
No, it's version 2, but let me show.
Sorry, I don't want to interrupt. I have a mic here for questions, or if you guys would like for the recording, you could just repeat the question.
Okay, yes, I'll repeat it now, thank you. The question was the version of the key vault. I installed engine 2, version 2 of the key vault, but I don't declare here. You made me think now. No, because I go to a store that I previously created, and this is V2.
Oh, that's what.
Yeah, yeah. So this is pretty much what you just saw. That's the environment that I have in my machine. The 3 cluster secret stores are these things that are not within a namespace. Our names they don't have a namespace. The external secrets do have a namespace, although we are working on namespaceless external secrets, and Vault running in my also cluster. The only difference is the value for every secret was hello from AWS or hello from Azure or hello from Vault. That's pretty much what I wanted to show you. And this is, as you've seen, this is certified to work on my machine, but I will give you a repo and hopefully you will get it to work on your machine too. So yeah, stuff that I didn't have time to demo. The push secret, I did show it. Generators, we have more. I show you just the password, which is like the simplest one. But we have like the real exciting ones are ACR, access token, ECR, and GCR. And Vault Dynamic Secret. Vault Dynamic Secret actually allows you to create AWS credentials dynamically. So we have those up and running. And the other good thing is we are in the CNCF sandbox. You probably already seen this. They showed it before. We're right there. You see us? Yeah, it's not easy. What about now? Insecurity and compliance. No? We are, trust me. There we are. Right there. So yeah, we are in the CNCF, which has been great. There's a lot of traction going on with the project, a lot of blog posts and articles about it. From AWS, from Red Hat, there's a lot of people that have written about how to get it to work. If you are not familiar with it, there's a lot of documentation. Our documentation, which we actually need to work on, but actually a lot of different articles from a lot of people that was interested in getting to know the solution. Also from IBM, Argo. And there's also a lot of content on YouTube. If you search for external secret operators, you will find talks like this one, or little videos that some influencers have done talking about it, about the project or something specific about it. So it's been really cool. So what's next? We want to stabilize and work more on push secrets. Push secrets is something really new. The thoughts behind it is to actually have the full cycle, the full synchronization of, so far we had the pulling, now we have the pushing. So a scenario could be, maybe you have all your secrets on AWS Secrets Manager, and you want to have them as a backup in Azure. Now you can do it automatically with a push secret that will grab every secret and push it to your Azure or whatever. We want more tests, more documentation. Obviously, I'm working on an issue about documentation. We want to reach general availability by this year, hopefully soon. And we need contributors, maintainers. Like I said, we're 5 of maintainers, a lot of contributors, a lot of people actually helping. If you want to, you can contribute writing code, testing, documentation. It's Oktoberfest friendly, so Hacktoberfest friendly, sorry. So if you want to win a t-shirt, you can create a pull request for whatever you want. We have tags for good first issue if you are new to Go, if you are new to open source. This project was my first project in Go. I had never seen Go before I joined the project. So yeah, I encourage everybody to take a look. And of course, sponsors are always needed. This is for the picture, resources, our website, our repo. We have community meetings every Wednesday, every other Wednesday. So not today, but the next Wednesday at 2 p.m. Toronto time. The agenda is over there. We have a YouTube channel with the previous community sessions. We have a Slack channel, and the demo link is the demo that I just showed. Everything is there, should be working as expected, and if you get it to work, please file a pull request so I can get the works on my machine certificate out of it. One more thing, shameless plug. I'm also an organizer for a few communities. One of them is Software Circus in Montreal, but I know they are starting in Toronto also in May. Go to meetup.com and check them out. And I'm also on the DevOps Days Montreal committee. It's happening this year, November 1 and 2. And the CFP is already open. Feel free to reach out and propose your talk. And with that, that's it. Muchas gracias.